All right, Erin, over to you.
Okay, well, welcome everybody. My name is Erin. I am an employee for Trout Unlimited, specializing in water projects in the Eastern Washington area, specifically the Yakima River Basin. I really wanted to start out with saying thank you to the Washington Trout Unlimited Council for being able to make all of this possible. They have put in an incredible amount of work to be able to bring this all to our volunteers and actually bring this to fruition. So thank you again. Really excited to be able to get this on the ground and going. Before I get started too far, how many of you guys have actually done this training with DFW already, the in-classroom training?
I don't think anybody, Erin. I think this is a totally new gang.
Oh boy, good luck, guys. No. Okay. Well, awesome. I'm excited to get going then. So, we have the barrier assessment and prioritization training. This is actually a training, or this slideshow is actually a training that was put together by WDFW and is the basis for their in-classroom training. So just a quick overview. We are going to do our in-class training today via Zoom, and then our hands-on training tomorrow. There's a lot of information that we will go over today that will make way more sense out in the field tomorrow. So if you don't necessarily get it today with the in-class training, don't worry, we will go over it far more in depth tomorrow in the hands-on training. So this training goes over the site information. Site information is going to be something that we'll go over a little bit more here in depth. But with the site information, you're going to focus on things like the overall area of the culvert that you're going to be assessing, with the site information, we really want to make sure that we take good notes on, to verify the type of surroundings above the culvert and below the culvert. We want to take lots of pictures. And like I said, we'll go over that a little bit more as we move on. We'll go over the level A and level B barrier assessment criteria. And this slideshow does have some information on dams and fishways, but that's not anything that we're going to be concerned with as far as our surveys out in the field. But I will quickly go through those here towards the end of the slideshow.
Erin, this is Steve. Steve Lang has a question there about, will there be any handouts or other materials that will be available for us to review and keep for our files?
And I'm sorry, I can hardly hear you with the wind and my trains in the background.
Oh, okay. Can you see the question?
Yeah, go ahead and ask your question.
Can you see the question from Steve Lang? Can you bring that up in your chat box?
It's in the chat, Erin.
And forgive me, I am not the most.
On the bottom, you should see a looks like a talking bubble. It says chat under it.
There we are. So will there be any handouts or other materials that will be available for us to review and keep on our file? So yes, there is. Actually, I will be taking you through our BAT website that is courtesy of the Washington Water Council. They have done a fabulous job putting all of the materials and the DFW barrier assessment manual is all on the website. And I'll take you through how to navigate to all of those. And a lot of the materials you can actually download yourself for reference. But we do actually have most of the information already printed out, laminated, and it will be in the files with you that you take out in the field. So you'll be able to have all of that in hand when you're there. But The website is a fabulous way to kind of familiarize yourself before you go out into the field. So this is just a quick overview of the barrier assessment manual. It can be found actually easily, quick Google, or on the Washington Council's website. And I will be able to show you guys here in a little bit where you can find that. But this is just a quick layout of the information that you can find in that assessment manual. And it's actually a pretty updated manual. It was updated in September of 2019. So yay for DFW on having a nice updated manual for us to be working from. Okay, and so here is just a broad overview of your site information. So on the site information, when you go there, you'll generally fill out the different site forms, and on those site forms, as we'll get to, there will be information like your latitude, your longitude, but you're gonna wanna, like I said, take a whole overview picture of the site itself. Pictures are a fabulous way for you to remember and evaluate the site. And you want to also look above and below the culvert and describe that whole area for part of your site information so that you get a broader picture of the entire culvert. So here is our site description field form. As I said, some of the most important information is going to be highlighted here in yellow. Your site ID is actually going to be found on the barrier assessment training website. The Washington Water Council, they actually have their own updated version of a barrier assessment map. And that map was actually produced by DFW. It selected out a number of sites that haven't been evaluated in a long time, 8 years or more, and a number of sites that need to be evaluated. So thank you to them for being able to pull that out and get that onto our website so we can have a more focused area of where we want to go. Although I will say really quickly that it is mainly west side streams and tributaries and that are listed on our BAT website. There is another website, and I will show you guys that website here shortly. That is the WDFW barrier site. And that one has the full list of all of the known barriers within Washington state. And you can use those websites to look at before you go out to the field to determine where you want to go and where you want to specify your surveys for the day. And some of those sites, especially on the BAT website, they already have a site ID number. And so we don't want to create new ones for sites that have already been surveyed, say 8 years or more in the past. We want to continue with those site ID numbers. But if we're surveying a brand new site that doesn't have a site ID and isn't listed on DFW's website or the BAT website, we have about 200 new site IDs that we can use to create. And that information, Brad, correct me if I'm wrong, will be at part of the small training manual that will be circulated here shortly.
What we'll do is we'll have contact information for those. And right now, Nick and Steve will have access to that information. So if you get to a site and there's no site ID, we can give you one.
Perfect, thank you, Brad. And next you can see latitude and longitude are two very important pieces of the site description field form that need to be filled out. We are using GPS units that actually will give you those latitude and longitude sites. So you don't need to worry about trying to pull them up on a Google map or anything. While you're on site, you'll be able to pull those up. Next is the fish use potential. There are a few websites that are actually pretty fabulous for being able to pull up the fish use potential. One of them is the Salmonscape website, and DFW has a site as well to be able to determine fish use potential. When in doubt, check unknown. You know, we don't really want to say that there's absolutely no fish use potential. There may be times, but those times are far and few between. So my recommendation is to try and determine a site that you want to go and survey before going out into the field. Do a little homework before you go and look up some of those websites to see if there is that fish use potential. And then
can you clarify what you mean by fish use potential there?
Is there the possibility for fish to use that stream?
So it's the whole stream, not just whether there's potential. Okay, I got
Yes,
it.
correct. Yeah, it's a whole stream potential, and that's why we say to don't just look at the culvert as a standalone. Look at the entire surrounding area of the culvert. You know, can fish use that stream even up to the culvert? And then the fish use criteria, the biological, mapped, physical, and other. The next slide will actually get into this a little bit more. And actually, it'll get into it a little bit more as we get further on, but here's just some more information about the site information, comments. I am always writing notes on the surveys that we do. The more notes and comments that you have about the general area and the general look of the culvert that you're surveying, the better you can recall your memory when you go to put all of this information in onto our website. And I do actually want to note really quickly, ownership is a big part of this too. And part of the reason why we say that we want you guys to kind of determine the sites that you want to go to beforehand, because we aren't going to be asking you to go and survey stuff on private property. Most of what you're going to be surveying is going to be on like DFW or state lands, county roads, those kind of places. So make sure that you know the property that you're going to before surveying, and that you're not ending up on a bunch of private property. So here is the fish use criteria and the hierarchy of that fish you know, biologicals. You know, are they observed? You know, do you see fish in the stream while you're surveying that culvert? Mapped, as I had mentioned, there's the Salmonscape website, the DNR water type maps. There's a number of different areas that you can go online and look up fish use potential, or the if it's considered a fish bearing stream. Physical, we'll see here on the next slide. And you know, has there been recently documented fish use in that stream? You know, maybe you had been there fishing earlier in that season and it wasn't listed on the Salmonscape website that it's a documented fish bearing stream, but you have personal experience as a documented fish bearing stream. Go ahead and use other as your criteria. So when it comes to the potential for fish use and the fish use criteria, we are broken up into the Eastern Washington and the Western Washington regions. Scour line, we will get into scour line a little bit further on here, but scour line widths are different between the Western Washington streams and tributaries versus the Eastern Washington, and that has more to do with the hydrology and stream shapes between the two sides of the state. So just really quickly, greater than 0.6 meters, which is about 2 feet for Western Washington, is part of that physical criteria, or greater than about 0.9 meters, 3 feet for Eastern Washington, and a gradient less than 20%.
Can you explain what scour line means?
We will actually get into scour line here shortly with some of the future slides.
Thanks.
So the scour line width. Scour line width is going to be the horizontal distance between the lines on either side of the creek where there is your normal base flow. In this picture, you can see kind of where the grass stops growing. That's going to be your scour line. You can see higher up where it may be to a bank full depth, but your scour line is your base average flow. And when you're measuring scour line on a creek, you want to do a perpendicular line to the creek, you also want to do a level line. I think we'll have some examples here in the next slide. Oh, hopefully my internet will keep up with you guys. Oh, come on. Ah, there we are. Okay. So as you can see here, we have our bankful width and our scour lines. Our scour line is down below. There isn't going to be anything really for major vegetation where the average bank or where the average river flow is. As you can see, the scour marks are produced as a result of water action that occurs with enough frequency to leave a distinct mark upon the soil or vegetation. So most of the time where the scour line is, you're not going to see, grasses or shrubs growing. Now I had discussed the bankful width, and that's where the river has come up high enough where it is at the very edges of the bank before it flows out into what would be considered the floodplain. You can see usually a vegetation change from where the scour line is up to the bankful width. Most of the time you're going to have grasses or some smaller shrubs between that scour line and bankful. And then once you get outside of bankful into the floodplain, your vegetation changes. But just a reminder for that site evaluation form, we're looking at just the scour line width. So as I had said before, you want to measure perpendicular to flow outside of the area where the normal stream function is influenced by in-stream features. So this is actually a really bad picture of where to measure scour line at, partly because as you can see, the person downstream standing in the stream is actually standing in a pool. You don't really want to be measuring in pools or major riffle spots. You want to try and find a spot in the stream that is representative of the entire stream that you were looking at. So places where there's major riffles, places where there's major pools is not necessarily where you're going to be wanting to do your scour line width. And bends are also not necessarily always the greatest place to be doing a scour line width measurement as well. One of the things to note is when you're doing your scour line width, you want to do it outside of the culvert influence. So here is a great picture of culvert influence. So you can see upstream of that culvert, there is a sediment wedge. That can be from what we would consider an undersized culvert where sediment is building up in front of that culvert because the culvert does not allow sediment to move through. So we would want to measure outside of that culvert influence and outside of where that sediment wedge would be. And you can see downstream of that culvert, it's almost like a fire hose with a lot of pressure, and it has created like a scour pool outside of that culvert. So we would want to measure downstream of where that scour pool is to determine the scour line of the creek itself. Just taking a quick look at my notes. So yeah, you're just trying to capture the basic geometry of the channel. So non-fish bearing streams, this is where that or the site information comes into play, where we're trying to determine whether we are going to find fish or not in the fish bearing streams. Non-fish bearing streams, we don't generally survey. When in doubt, if you think that there is the potential or the possibility for fish, it's always great to note that culvert and do a quick survey on it, but we don't generally survey non-fish bearing streams. So fish passage barrier conditions. When we're talking about the barrier conditions, we're generally focused on adult fish. We're not necessarily talking about like sculpin or lamprey. This is based on the jumping ability of the weakest swimmer. And for the weakest swimmer, we're gonna be really looking, the protocol actually looks at what can a 6-inch trout jump into. So not really a lot of these pictures, actually none of these pictures are going to show what a 6-inch trout could necessarily jump into. As you can see up here in the top left, both of those have significant drops out of the culverts that would be a fish barrier to anything that is a 6-inch trout. Flow, high velocity is also going to be a fish barrier. When you have either undersized culverts or extreme flows, you're not going to be able to have some of those species going upstream, especially, and remember, we are talking about the weakest species being able to make it up through these culverts. Down here, this is a low flow situation where there isn't a significant amount of water coverage for them to be able to make it through. And up here, you have a culvert with an apron, and oftentimes these aprons can be barriers in and of themselves just because of the low flows. And as you can see, sometimes the significant drops off the end of those aprons coming out of the culvert. Just going over this again, it is based on the salmonid swimming abilities, the velocity and water surface drop criteria, as I said, for the 6-inch trout. And when we say a depth barrier for the water flow, depth is actually being determined for an adult Chinook. And I just wanted to go over really quick. They don't expect a site to pass fish all the time, just most of the time. So when we're doing our assessments, we aren't, and we'll go through some of the flow charts that show percent passability, but they aren't looking for 100% passability on all culverts. And then this slide really quick, we aren't going to pay a whole lot of attention to this slide. This is just generally the DFW's measurement for flow and velocity and depth, and how they determine the QFP is the fish passage for high flow. And most of this information is actually going to be identified in a level B assessment, which will end up becoming part of DFW's QFQC, which they do with their own hydraulic modeling. So don't get overwhelmed by this slide. This is modeling that gets done later on.
A quick question on that. For those of us who've seen pictures of the salmon crossing the roads in like the Carnation area where they're actually out of the water, but they still manage to cross, how do we know when something's too shallow?
So we'll actually have some flow charts for you that will show the slope and through that slope you'll be taking measurements of water depth and the length of the culvert. And so with those percentages that we get with the overall slope that we calculate out, there is later on a percent passability chart, and we'll get to that. hopefully, there we are. So adult fish passage requirements, the velocity should not exceed any of the flows. And velocity criteria with the length of the culvert over 100 feet long, the max velocity is 4 feet per second. 30 or 100 to 200 feet long, the max velocity is 3 feet per second. And over 200 feet long, the max velocity is 2 feet per second. But as I said, we'll be calculating some of this and we'll get into it a little bit more when we do our culvert assessment field form. So I wouldn't be focusing on this too much just yet. This is just the worst picture ever. Water depth at any location within a culvert must be 1 feet at any flow. So as I said, we'll get more into this as we start filling out that level A assessment form.
Sort of like that picture, Erin. I think that's sort of cool.
Oh, it just grates on your nerves.
It
No
does.
pun intended.
Yeah.
So water surface drops at the inlet of the pipe, the outlet of the pipe, or any interior of the culvert cannot exceed 0.24 meters. And so I actually want to take a moment here. All of our measurements are going to be in meters. We aren't going to be doing any of our measurements in feet. Unfortunately, our rangefinders to do length or distances is actually in feet, but we'll be converting those over to meters. And Brad, correct me if I'm wrong, in our instruction manual, we will have a conversion for our volunteers.
Correct. In fact, I am working on a new chart, and it'll actually have a section for feet, and then there'll be another box for meters to remind you on those measurements that you need to adjust to meters.
Wonderful. Perfect. So what is passability? So with passability, it's not just a yes or no. They have broken it down into a percentage of a level of passability. And so you can see here, they've got it broken down into the fourths. And we'll get more into that again as we get further into the assessment and our flow charts. So here is our flow chart, the overview of the flow chart. So you encounter a culvert, you start recording the information about that culvert with the site information, and then you move into your level A barrier assessment. Your level A barrier assessment, once you have put down all of the information and filled it out, you'll be able to use that flow chart at the end of it to decide if it's a barrier or if it is not a barrier. If it's not a barrier, you'll stop your assessment. If it is, you'll move, or if it is an unknown status, you'll move on to the level B barrier assessment. And Brad, correct me if I'm wrong, but we are going to not spend as much time focusing on level B barrier assessments out in the field. We were thinking about actually making that its own training.
Correct. We're just going to do A tomorrow. What we found, everybody, and this has been from 2 trainings, and I was involved in both of them. By about 2:30 or 3 o'clock in the afternoon, when we were getting to where we were going to do the barrier B assessments, everybody's getting pretty tired. Their brains are also pretty foggy with all the information that they've already tried to absorb for the day. And so, yeah, what we really need to do to start with anyway is level A assessments. And then if we actually do find one that has to be a level B, we can get some people together and go back out and check that out. But most of our assessments will be level A only.
Yeah, and level A assessments are still great assessments for us to have. And if you get to a point where a barrier is or it is a barrier, it's unknown status, and not a big problem. I think having a big batch of those level B assessments for us to go out and just assess as a level B, given that we have that fresh level A assessment already completed, goes a long ways. So here is our level A assessment sheet. And I just want to note that on all of these level A assessment sheets, instructions are on the back of every form. So you can see here, they say 1, 2, 3, 4, all of that. There is corresponding instructions on the back of this level A culvert for each one of those numbers. So if you have a question, or say you're trying to scratch your head, trying to remember, how do I fill that portion out? Flip it over to the back side. You have all of your information on how to do that on the back side. So as we did on the site form, you'll fill in the site ID, and we will get into a little bit further the culvert number and the different types of culvert materials, and all of those abbreviations for those. And we will go in a little bit further and explain how to, or what each one of these are and how to fill them out. So culvert number. When we come up to a culvert, the way that we sequence these is, so on the left side of the screen, there's only one culvert here. So that is culvert 1 of 1. So 1.1 is culvert 1 of 1. When we're looking at culverts and we have multiple culverts, the way that we are looking at them is as a river would. So from the top of the culvert looking downstream. So when we number these pictures are backwards. 2 culverts right here in the center of the screen. This right culvert would be culvert 1.2, so culvert 1 of 2. And the left culvert would be culvert 2 of 2. When you're doing site assessments with multiple culverts, you're going to be doing a level A assessment for both culverts. So each one will have its own level A assessment. And then same here with the one on the right-hand side, you have your 3. So your right one would be 1 of 3, 1.3. Middle one would be 2.3, and your left one would be 3.3. Any questions on how we sequence the culverts?
I was just going to say, Erin, we have a chance tomorrow. You'll be doing a dual culvert where there's double culvert, so you get a chance to experience that.
Yes. So when you have multiple culverts, there are times that you will have some of your culverts higher than the others, and you will run into overflow culverts. So the way that we look and measure to determine if we have to do a assessment on the culverts is we do our lowest culvert, we draw a line through the center of it, and any of the culverts that actually fall within that line are going to be assessed. So now, as you can see in this picture, above the red line is the overflow culvert. It is outside of the red line, so we will not survey the overflow culvert. But it is good to note in your notes or your comments on your level A assessment that there is an overflow culvert and on what side it's on. So here is a picture, a nice example of overflow culverts. The next slide will actually show you the downstream version. Oh, sorry, maybe that's a little bit further on. So yeah, here's a good example of an overflow culvert that would not be surveyed, but it would be noted in your comments. Here is another strange example of an overflow culvert sitting on top of another culvert. So we have our materials for our culverts. Here we have the top one is going to be your precast. Those are generally going to be around cement precast culvert, and generally pretty easy to identify. And then you have your cast in place concrete culverts. This is a spot where I'm going to note that there's a couple of different forms for thinking about these cast in place concrete forms. Anything over, so federally, they look at anything over 20-foot spans over those as a bridge and not as a culvert. DFW determines them as culverts as long as they are within the waterway. If the span of the bridge or culvert is outside of the stream flow, and I think that there's an example of that later on. If it's outside of the stream flow, it's not considered a culvert. So we're looking at specifically culverts that are inside stream flow. And then you have your steel and your aluminum corrugated metals. We do have magnets in our kits, and it's always a really great idea to just take your magnet really quick to the side of that culvert, because sometimes you'll run into an aluminum culvert that looks like it's corroded and it could be a steel culvert, but in fact, it's actually aluminum. So when in doubt, take that magnet out and stick it onto the side of the culvert and just double check yourself. That way you're writing down the correct materials for that culvert. And then here you have the steel culvert. These are probably fewer and far between compared to the corrugated ones, but these are a smooth-sided steel culvert. And then down below you have your plastic culverts. They can be corrugated inside or smooth. And then you have your steel or your structural plate culverts. Generally, these ones are pretty easy to note by the fact that they have to be brought in and assembled in place. You can see that usually they're bolted or riveted together on site. The structural plate ones, oftentimes, not always, but oftentimes, don't have bottoms to them, but you will use your gravel probe to determine whether or not they have a bottom to them. And we'll get further into using the gravel probe to determine bottoms. But they have the structural plate ones in both steel and aluminum. Again, taking out that magnet to determine which kind it is the easiest way to make sure that you have the right materials. Next, we have our timber and our masonry. These ones are also really uncommon. Timber ones you can clearly see are a wooden structure. A lot of you might find them in some of the higher, older Forest Service roads, or even actually over here in the less populated Eastern Washington areas. And then you have the masonry ones. These ones are not as common. Although I will say I did see a lot of them when I was traveling in Europe. And so this is just some jargon that we'll go over really quickly on how you talk about a culvert. You have your invert down at the bottom and your soffit at the top, and those are both internal definitions on the culvert. And then you have your crown, which is on the outside top of your culvert. And when they talk about span of a culvert, sometimes you may get some that are angled like this picture here at the bottom. And when we're measuring those, we don't want to measure the angle. We want to measure the true span side to side. So we try and measure inside of the culvert to get that span of the culvert versus this red angle line, because that doesn't give us a true span of the culvert. So when we're doing our level A assessment, one of the questions on there is the span and the rise of the culvert itself. So when we have culverts like this squash type culvert, what we're looking for is a measurement at the widest point of the culvert. So you can see here at the top right, they're showing with this line right here, hopefully you guys can see my cursor, they're showing that that's about the widest point of the culvert, and that's where we want to measure our span. And then our rise is going to be from, again, the widest point in the culvert, so directly at the bottom all the way to the center of that soffit. Sometimes and oftentimes you will find culverts that actually have sediment or gravel at the bottom of the culvert, and we want to be able to make sure that we're getting a true rise, a full rise on the inside of the culvert. So right here at the bottom right is a picture of a gravel probe, and you will use that gravel probe to push down through the sediment or rock to determine where the bottom of that culvert is. And once you have some practice or experience in this, you'll definitely know when you hit the bottom of that, it has kind of a metal ring to it, a ting when you hit the bottom of it. And so that way you know that you found the bottom and you can then proceed with your measurement for the rise. Water depth in culvert. So the water depth, you want to measure 6 inches in from the end of the outlet of the culvert. So the downstream side of the culvert. Sometimes there may be like leaves and debris in the end of the culvert, and you want to kick all of that out of there if you can, and then wait for the flow to return to normal before you do your water measurement. Other times you may end up with large rocks or maybe trees at the end of the culvert. So measure further into that culvert to get a better water depth measurement. Also, sometimes a lot of the older metal or steel pipes may have some rust, and you'll see that the water is actually flowing through the hole in the bottom of the culvert, and you'll want to measure 6 inches in back from that hole. Culvert shapes. We have our round culvert. It is the same rise over span, so it's as wide as it is tall. You have your squash, and then you have your elliptical. And ellipticals can be either really tall or short and wide. With the ellipticals, it's not as common to see those, although there is times that you may run into them. And then you have your box culverts. A lot of times those box culverts are going to be those concrete structures. Rarely, sometimes you may find them in a wood box structure. And then you have your arch structures. Now, your arch structures are harder to identify because you don't know if there's a bottom or not, but you can actually take that gravel probe and kind of go toward, you see those boxes at the bottom of the arch. Those are the footings of arches, and you can take your gravel probe and see if you can actually find a footing for the arch rather than trying to see if it's incredibly deeply buried round or box culvert. And then you have your water surface drop. Water surface drop can be going into the culvert, in the culvert, and outside of the culvert. And actually, we'll see a little bit of this tomorrow, where one of the culverts that we'll be surveying actually has an interior slope break, a water surface drop interior, and it also has an outfall drop. And so we want to actually measure the water surface drop from the top of the water surface. So I hope you guys can see, let me know if you can't see my cursor on here, but you want to measure from the top of the surface down to the top of the surface. That is going to be your water surface drop. And when you have culverts that have multiple water surface drops, you want to actually record, if at all possible, all of those water surface drops that are leading up to, in and out of the culverts. And yeah, so just here at the outfall drop, again, we are measuring for the water surface drop. We are measuring the top of this water right here coming out of the culvert, and we are measuring from the top of the water down here at the bottom at the drop. So here's a great example of water surface drops. You can see right here we would be measuring from the top of this water surface to the top of this water surface. That is your drop. Now, if you look at this upper arrow in the left side, you can see that there actually is another water surface drop leading into the culvert, and we would be measuring that water surface drop as well. There are two culverts in this picture, so we would be doing level A assessments and water surface drops for both of those culverts. Now, you can see here that there's a bunch of rock and riprap material that's sitting at the bottom of this culvert, and you might think that, yeah, it might be possible for, you know, fish to get up there, but you need to think like the smallest fish that can get up there, the 6-inch trout. Can it jump that giant water surface drop? So when you're looking at these, make sure that you think like a fish when it comes to a water surface drop. And you want to be measuring, as I said, the top of the water inside the culvert to the top of the water down here. So that's a really big drop for fish. So these are a good example of aprons. On the level A assessment form, it asks if there is an apron, either upstream, downstream, or both. Now it's good to note some culverts may actually have a beveled end to them, and those are not aprons. Those are just part of the culvert themselves. An apron has a true water diffusion outside of the culvert. Any questions about aprons?
By the bevel, you mean it's part of the structure to the metal culvert, for example?
Yeah, so sometimes like here on the left side picture, this was angled out and, you know, came a little bit further out at the bottom of the culvert. And so, you know, the top was further back in and the bottom was further out. That's a beveled culvert. And those are not aprons. An apron, as you can see, actually comes off the end of the culvert itself and diffuses water before it actually goes back into the stream.
You will get a chance tomorrow to measure a quite significant water surface drop. As I was mentioning, why you needed your waders.
Yes.
Because you will be wading in the water to measure that drop.
And then we will be also doing the length of the culverts. Length of the culvert is end to end. It's good to note that if a culvert has an apron on either end, you are measuring from the length. You will be measuring two lengths, the length without the apron and the lengths with the apron.
Hey, quick question on the length.
Yeah.
If that was a beveled tube, what's the length? Is it the shortest length or the longest length?
The longest length. So the length that the water is traveling through.
Okay, so assuming that both ends are beveled out, you would measure from the end of the bevel to the other end of the bevel.
Correct.
Okay, thank you.
Culvert slope. And this is where all of our lovely middle school, high school, college math comes back into play. Rise over run. And for rise over run, to get your rise for culverts, you're going to take your upstream elevation minus your downstream elevation, and you'll divide that by the total length to get your rise. And we will be practicing this out in the field. It will make far more sense as you're putting it to use on the ground. And then we have road fill depth. And road fill depth is measured from the bottom of the culvert to the crown of the road above. And this is not necessarily an exact measurement, it's just measured to the nearest whole meter. And it is always measured from the inlet side, or sorry, the invert side. So like I said, the very bottom of the culvert, which is your invert of the culvert. And one of the questions on there is going to be countersunk, yes or no. And this is where I said it's really good to determine the type of culvert that you're working with. And you have to use the gravel probe at times to figure out whether it's round, elliptical, or it's just an arch. And you can see here in the picture on the left-hand side, there is the gravel probe right there in the center, pushed down to determine if it's countersunk. And countersunk is bed material greater than or equal to 20% of the culvert rise at the outlet. So remember, rise is how tall the culvert is overall inside measurement. So if the gravel or sediment or bed material is over 20% of that overall measurement of the culvert, it is countersunk. Oh, hopefully my computer will keep up. Give it a minute here to try and load. Does anybody have any questions while we're trying to get this to load?
As far as the measuring the water depth in the culvert, you had mentioned earlier about measuring 6 inches back in from the exit. But that was, as I recall, the picture was a corrugated culvert. So does it matter, you know, whether we take it from the bottom of a corrugation or the top?
Actually, you know, that's a very good question.
Somebody asked that question. I'm trying to remember what Luke said, and I don't remember. So we'll have to maybe I can text Luke and ask him here while we're doing that. Unless you know, Erin. Sorry, I didn't mean to jump on you.
No, that's absolutely perfect, because you know, it's a really great question, and it's actually not one I've had to answer before. So if we can get that verification from Luke, that would be perfect. Oh man. So what this picture is actually trying to show is the type of sediment into, and I'm sorry that it's not loading and my internet is definitely not behaving. It's trying to tell you the amount of sediment in a culvert and whether you would determine that as countersunk or not. So like the top picture, you can see an even layer of sedimentation or bedrock in the bottom of that culvert, and that would be considered a countersunk culvert. Now, the second picture, where there is no sedimentation or bedrock material at the top of the culvert, but there is at the bottom of the culvert, that would not be considered a countersunk culvert. So countersunk.
Question on the countersunk. We know of an area, in fact, we used to do a fish count where there's a bridge that I'm, based on the training so far, I would consider it to be a culvert. But it has filled with sediment over the years significantly. Would that be considered countersunk, even though that's all natural?
Yeah, so it could be considered countersunk as long as you have sediment throughout the entire portion of the culvert or the barrier. So like this second picture is showing, there's only sediment at the outlet end, but there's not any at the inlet end. This would not be considered countersunk. So you want to make sure that when you're looking at the sedimentation, that it has fairly consistent, even sedimentation throughout the entire culvert length. And I wish it would load. I am so sorry, guys. On the BAT website, this slideshow is actually on there. So if you want to go back later on, you can go through these slides again and actually take a look at this full picture. And it does actually have words and descriptions that go with to show you, yes, this amount of sedimentation is countersunk, or no, it's not.
Erin, this is Steve.
Yes.
To kind of address that countersunk thing, my understanding is that when culverts are placed, they aren't placed with any materials in them. So countersunk is all natural material in most instances. Is that correct?
Correct.
Okay.
Yeah, it's very few and far between that they're actually going to put rock and sediment into a culvert when they place them. They actually hope for that natural flow of sediment to come through the culvert, and that's why through a lot of today's engineering, they actually plan for that kind of flow of sedimentation through the culverts, so that culverts aren't actually barriers to sediment. As we all know, rivers move a lot of material, and a culvert shouldn't be inhibiting that movement of material. So we'll move on. The next one is backwatered, yes or no. Backwatered has a couple of caveats that go with it that are worth noting. And the first is the average velocity through the entire length of the culvert is visibly slower than the average velocity in the adjacent channel, or very little or no visible flow through the entire culvert length. So when we talk about a culvert itself being backwatered, there should be minimal to no flow through the culvert itself. It doesn't mean that they're talking about backwater in front of the culvert or backwater at the outlet end of the culvert. It is talking about flow through the culvert. Does that make sense?
I'm not sure. So when you say the adjacent channel, you're talking in effect about having two flows, right?
So if leading up to the culvert and after the outlet of the culvert, you may see significant flow. But that flow, if you see inside the culvert, is not flowing the same as the flow going in or the flow going out. It is considered backwater. So say you have a pretty good flowing stream coming into the culvert, and it looks like it's actually flowing pretty well outside of the culvert, but inside it's very still. There's almost no movement through the entire interior length of the culvert, then it is considered backwatered.
But how is that possible? If you've got flow going in and flow coming out, presumably you've got flow throughout the length of the culvert.
And this is where we would actually, how do we put this? It's not very common to see a backwatered culvert. But it is worth noting if you do see one where there is limited to no flow inside of the culvert itself while there's flow outside of the culvert.
I would think the only way that you would run into that situation would be if the cross-sectional area of the flow within the culvert is greater than the cross-sectional flow on either end. I mean, you'd have to have more volume that the water's traveling through for it to slow down.
Yeah.
Yeah, what happens, for example, would you consider it backwatered if the outlet of the culvert had a lot of debris in front of it, such that there's a very narrow area where the water does flow out of, but a very wide area through the culvert that doesn't look like it's flowing much at all.
And that is a possibility. And if there is material in front of the culvert that's blocking the flow and creating it to be backwatered within the culvert itself, it is definitely worth noting in your culvert assessment form and taking thorough pictures of.
Should we be removing that stuff in order to make these measurements?
When safely possible.
Okay.
You know, if they're large trees and logs and it's going to take more than a couple of hand movements to pull them out, then I would say no. We don't want to put any of our volunteers in danger by removing material from the ends of culverts, which is why I say it's good to note it in your culvert assessment form, and to take good pictures of it, because a lot of that stuff can be more maintenance issues for the landowner. So here's another example of a culvert being, you know, how to determine if the culvert is being backwatered. So if it looks like there's you know, not a whole lot of flow in the culvert, it's not really moving, but you see a good amount of clear flow going into the culvert. It may be slower on the backside of the culvert as well. But if there is almost no flow through the entirety of the inside of the culvert, you would consider it backwatered.
And we'll have a discussion about that on where there's two culverts tomorrow. And we'll have to, because the outlet and the inlet are different. So this will be a good example to think about when you're there tomorrow.
And then next we have gates. We're not going to be dealing with a lot of gates in most of our surveys. And this is, gates are worth, you know, taking pictures of and noting the latitude and longitude. But this is where your homework comes in before you actually go out and do your site surveys. A lot of the culverts, irrigation ditches, they have been noted in the barrier assessment websites. So we don't really want to be surveying anything with like the tidal floodgate the tidal gates or irrigation floodgates. We're just not going there. And then racks, we're actually going to be experiencing some of those tomorrow on our double culvert. So that will be awesome to be able to survey some of those. Racks come in a bunch of different forms. It is incredibly rare to see one of these at the bottom right-hand side. We don't run into those hardly at all or very often. But we'll get into a little bit further on the measurements for racks and what's considered passable and what's not passable with those racks. But we do want to note on our level A assessment form whether or not a culvert has racks on it. So here you can actually see our parameters for measuring whether or not a rack is passable by fish. And we're looking actually primarily at Chinook as our indicator species for passability. So if the bars on the rack are less than 0.3 meters wide, it is a barrier. And then there's actually on the, if I remember correctly, on the back of, give me just a second, I've got my level A assessment form here in front of me. There is also, and I'll have this with me tomorrow too, a measurement for the height of your rack as well, on how tall those vertical gaps have to be for being a barrier. But if I remember correctly, it is, if it's less than 0.3 meters and Chinook are present, so 0.3 meters wide and tall, it's a barrier. And it is important to note that this is, again, where our homework comes in before we go out to do a site survey. We want to know if Chinook are present or not present in the stream that we're going to be surveying, because if Chinook are not present, the rack sizes can be much smaller at 0.24 meters. Fishways. So fishways, man-made structures to facilitate the passage of fish through the barrier, or even leading up to the barrier. So here you have kind of a step pool system leading up to the culvert. A lot of times that is put in at the same time that the culverts are installed. It's important to note here too that some of these can be confused with fishways, with grade controls. And sometimes they install the grade controls to help stabilize the channel after they've installed the culvert. And so a lot of these actually look like grade controls to me and not necessarily fishways, but this one here with the internal baffles inside of the culvert is considered a fishway, and these are designed to help the fish move through the culvert. Again, these are an older design. You probably won't run into these very much out in the field. And again, the bank full width. So we kind of went over the bank full width when we were talking about the scour line width, but bank full width is measured at the top of the bank before it crests the edges into the floodplain. It's fairly easily notable by the change in the vegetation, the slope going out onto that flattened floodplain. And it is different than the scour line width.
So if there's different elevations on either side of the stream, you go with the lower side. That's where the
yes, the first place that the river would flow over.
Okay, thank you.
And when you're doing that kind of measurement, you want to do a horizontal, fairly level measurement from the lowest bank point. So you don't want to do a measurement where you're angling from that lowest bank to the far upper bank, because that's an unrealistic representation of the stream. You know, you're not going to be able to get water up to that really high mark. So say this side was much higher, you don't want to be measuring from down here to, you know, that high point, because the water would be flowing over the banks of the other side and would never reach the other side of the high point. So we're measuring bank full at a level distance from the lowest side bank where the water could overflow into the floodplain.
Right. So another question about this, this depiction. What about getting the scour line width? I mean, seems like that could be difficult at times, depending on how much flow there is.
It can be difficult at times, depending on how much flow there is. And so one of the things that you may consider when you're wanting to survey a specific area is the time of year that you're surveying. You're not going to want to go out and survey when there's high flows or, you know, spring runoff or big rain events. You want to go when there may typically be an average flow. That way it'll be easier to determine the scour line width.
Right.
Here is a slightly hard picture to look at bank full versus scour line. But you can see down here at the bottom with the scour line, there is absolutely no vegetation growing along here. So it's pretty easy to determine where the average flow is just because of the lack of vegetation. And bank full, you can see there's actually the change from maybe some vegetation along the edge to, you have your ferns and your trees growing, and that's a definite vegetation change. And we'll be practicing more of this when we're out in the field tomorrow. And as with anything, practice makes perfect. Okay. Oh. And so, yeah, just covering again that you want to measure horizontal or and perpendicular to flow from a point on the bank where water begins to overflow into the active floodplain. And we've gone over most of this. So this is where I was talking about there may be instances that you run into where one bank is lower than the other bank, and your overflow is going to be at that lower bank before it will be the other bank. So you're going to do your horizontal measurement as level as you can from the lowest side bank. And so when you're doing your bank full measurements, there's some areas that you really want to avoid, just like the scour lines. You want to avoid those big pools, big water drops, and sharp corners. You're really looking for an overall representation of the stream when you're doing your scour line and your bank full width measurements. Plunge pools. So plunge pools can happen a lot coming out of culverts. When we're measuring our plunge pools, we don't want to measure the entire pool itself. We are measuring from the end of the culvert. And then we are measuring to the downstream control, or where you may consider the highest point that's actually holding that pool in. So that from the end of the culvert to your downstream control is going to be our length measurements. And then our width measurements, this may be hard, especially in some drier times. And like the culvert, one of the culverts that we'll be measuring tomorrow has what would be considered an obvious plunge pool. And when we surveyed it earlier in the year, there was actually no water flow. And so you have to use your best judgment in measuring the width. And we'll be measuring that at the scour line, not at a bank full line, but at the scour line is where we'll be measuring our width at for those plunge pools. So to get back into when we're taking photos of our surveyed area, on the left-hand side is a good representation of how we want to do our photos of culverts, and you want to do your upstream and downstream views of the culverts. And you also want to take pictures looking upstream and looking downstream, above and below the culvert, so you have a good representation leading up to and exiting the culvert. We do actually have machetes in our packs. And so the pictures on the right-hand side are good representations of when we would be using our machetes to clear out some of that debris, number one, so that you can get to the culvert and do accurate measurements of the culvert itself. But two, you want to be able to have all of that vegetation cleared out before you take a good picture of the culvert itself.
And we want to be real careful tomorrow. We don't let Steve Lang have a machete. I mean, it's dangerous for all of us. So. Sorry about that, Steve.
So here's our first flow chart leading into our collected level A data. So we collect all of our data on the barrier, and as we're looking at our data, we see that there is, is there a water surface drop that's greater than 0.24 meters? And you can see how it just moves us on through this this analysis on whether to determine it's a level A or whether it's a barrier or not, and whether we need to move on to a level B assessment. It's good to note here too that when we're doing this, you actually may have multiple things within your assessment that can consider it a barrier. You know, whether it's your water surface drop or the culvert span or the slope of the culvert. You may have multiple things that play into whether you think it's a barrier, but you want to determine that based on the biggest identifier. So say that your slope is not greater than or equal to 1%. But your water surface drop may be a little bit more than 0.24 meters. You're going to consider it a barrier because your slope is your biggest inhibitor. So assigning passability to a level A barrier, this is again criteria, and we actually have copies of all of this in our field packet, so you guys can reference this while you're out in the field. And again, this is where we actually talked about, you know, the percent passability, that it's not just a yes or no, but there actually is percent passabilities. So as we said, greater than or equal to 0.24 meters. So, you know, if it between 0.24 and 0.49 is actually considered 67% passable. Anything over 1 meter is not considered passable. And for our slope, we actually, it's broken down in between anything less than 18.3 meters in length, less than or equal to, and anything over 18.3 meters in length. They have different measurements or percent ranges that are acceptable. And so, you know, the less than or equal to 18.3 meters in length, say that you're 2.5% slope, you'd be 33% passable. But say your slope was 33% passable and your water surface drop was 67% passable. You would be basing your determination off of the least percent passability from this assignment. So does that make sense to you guys, that we're trying to use the least passable value?
Yep.
Multiple culvert crossings. So as I said earlier, we're going to be doing collecting level A data on all 3 of these culverts, and they will be each one their own individual culvert that you'll be doing a level A assessment on. And just from looking at this picture, if we draw a line halfway through the lowest culvert in the picture, you'll see that this is not considered an overflow culvert. It would still be measured and assigned in the level A barrier assessment. But these sets of culverts would maybe not be considered a barrier, because if even one of these is passable and not considered a barrier, we want to go back to thinking like a fish. They're going to use any one that's available. And if there's one of those 3 that's available and passable, it's not considered a barrier. And on the BAT website, we have one of the older DFW barrier or level A assessment training videos. And if you guys are getting ready to go out into the field and it's been a little while since you've done the training or done any hands-on, this is a really great video to go back to. It's pretty short, less than 15 minutes. And it takes you through the full level A assessment really quick, so you can kind of refresh your mind before you go back out into the field. Some of the information on it is a little bit old, because you saw earlier we had that nice colorful flow chart for the barrier analysis. But most of the information is still going to be the same. Just utilizing this video to refresh ourselves is a really great resource, and it's on the BAT website that the council has put together. Level B. But before we get into the level B, this is a great image of the rotating lasers that we're going to be using tomorrow. The rotating lasers are auto leveling. They're pretty easy to use, especially once you get your hands onto them. And you want to think about them as having this level plane that they're shooting out to do all of your work off of. So your level A, or I mean your level A will be using these for a lot of your measurements and heights, and so we'll be able to get a lot of hands-on with those rotating lasers tomorrow. But we will utilize them a lot more as we get into the level B. And so I'm actually going to go through fairly quickly with the level B assessment, since we're not going to be going too far into depth with them in the hands-on. And I think, Brad, correct me if I'm wrong, with our level B, I guess, training that we want to do, we'll probably go a little bit further in depth on level B trainings.
Correct. What we can do tomorrow, we can just talk in general that, you know, if you go through your A assessment and it will tell you whether level B assessment is needed, I think that'll be just sort of good enough for people to get sort of a feel for, you know, what, I guess when maybe they would be needed. And because, you know, Erin, in my listening to Luke talk, he just talks about a handful of times or a couple of handfuls of times he's actually had to do a level B assessment. So many of them stop at level A.
Yeah. And so I will just touch on all of this information. So don't become too overwhelmed by the information that is the level B assessment. But this will just kind of give you guys an overview of what is entailed in that level B. Here is some of the information or the tools that we'll be using tomorrow. We will be using the Stadia rods. Our Stadia rods are in metric. We do not do anything in standard measurements. And so when we're looking at these Stadia rods, they have those sharp points sticking out on the measurements themselves. And that's where we're going to be looking at for our measurements. And so like this one right here, that would be considered 0.95 meters. So familiarizing yourself with metrics or the meters and being able to read the Stadia rods, it's something that we can do before we actually head out and start practicing using them. It makes calling out your measurements while you're doing an assessment a lot easier. So in level B, they do have you set a datum or a benchmark of where you'll be doing all of your measurements from. And benchmarks can actually be anything out in the field, but you want it to be something, ideally something that you can come back to in 5 years and use as your reference point to do another survey from. All of your datum or benchmarks are going to start at 100 meters. It will make more sense if you go through the level B and do these out in the field, but everything starts at 100 meters when you're doing your datum for the level B.
You know, Erin, I don't know if I'd spend any time on this. I think this is going to confuse people since we're not going to be doing it tomorrow, and it's really different than the level A.
Yes, they are.
Yeah. Let's just blow by these slides, and when we do another training, and we've actually got some we want to go back and measure because they need a level B, then we can do a level B training, and then it'll make sense. So
yeah, the level B trainings, I mean, they're not difficult, but you know, once you've gotten through all the hands-on with a level A assessment for the day, trying to add a level B on top of that, having gone through the training with you guys, your mind was a little fried by the end of the day.
definitely, and level B is, I don't think it's quite as straightforward as level A. And so,
No.
yeah, it's more of a challenge.
Yeah, and I would encourage anybody who really feels like they're going to be able to spend the time out in the field to go or to sign up and do the level B assessment, especially after they've done a few of the level A's out in the field and they want to maybe do more, or, give back more. The level B would be really great to have a few qualified individuals who are able to set out and do those, especially if we get batches of them from folks going out and doing level A's. So I had talked earlier about other fish passage features. We won't be focusing on any of these, but they were worth noting. So non-culvert crossings such as bridges, and then you have dams, fishways such as, through towns. These are fish passage features that we're not going to be measuring. We aren't going to be using the non-culvert crossing evaluation form. There's areas such as fords or punches, old washouts. We're not going to be measuring those as potential barriers.
Where do you draw the, I think you just came to it. Never mind.
Yeah. So the arch culvert versus a bridge, and I kind of went over this in the very beginning. The federal highways, they actually consider anything over 20 feet wide to be considered a barrier, or to be considered a bridge. DFW considers anything that a bridge that's outside of the stream channel. So this bridge vert, you can see that it is actually not within the bridge channel. It's up on what might be considered the banks of the stream itself. So it's not considered a barrier or culvert. Does that make a little bit more sense?
Well, what about one that the whole stream runs through it, but it's more than 20 feet?
So the entire, so if
all the wall on the bridge.
So the water is wall to wall on the bridge?
Yeah.
You could probably measure it, but I'm willing to bet that it's not going to be considered a barrier that is in need of assessment or correction. Remember, most of the evaluations that we're doing for all of these culverts is to assess whether these culverts need to be addressed. We're looking to see if they're passable for fish, so that, if they aren't, we can start looking for funding to fix these as barriers.
Erin, let's go ahead and let's take 5 minutes. I think it's time for a bio break and so forth. We've been going for an hour and a half. You probably need to let your voice rest for a minute or two. And then I'll go ahead and stop the recording or pause it, and then we will come back. Let's see, what time is it? Let's come back at 2:40. How's that sound?
Perfect.
All right.
Okay, so back into just a really quick overview of other things that we will not be surveying. Dams and man-made structures. You can see the earthen dam with the culvert in it. We won't be surveying anything like that, especially on lakes and ponds. We won't be doing any of the dams on larger ponds as well, overflow spillways. None of those will be surveyed. And we won't be using the dam evaluation form. So, and then the outlet types, we won't have to worry about any of those. Culverts versus dams. This is not considered a dam. This is actually considered an inlet to underground stormwater. Once again, stormwater, this would probably not be considered a fish-bearing stream, so we probably would not be surveying this anyways, as it is highly unlikely that you'll be having fish flowing up out of that stormwater drain into the stream above it. And just some other quick views of dams that we won't be going through. Let's see, and yeah, the gates on any of the culverts, do your best to do some of your homework before you actually go out into the field so that you're not surveying culverts with tidal gates or flood control gates. Definitely won't be surveying any beaver dams or log jams. Log jams is a whole different story. And if you guys, side note, the wood dam surveys that we will be doing trainings on later, definitely encourage all of you guys to do that after having gone through the wood dam surveys. They're fun. I had a blast doing the wood dams, both natural and man-made. So if you get a chance to do those trainings as well, I would really highly encourage you guys to do those. And this is a good example of a fishway associated with a natural or man-made feature. A lot of those fishways include like these step ladders to get up. Those are just important features to note and may not necessarily consider a culvert or a barrier, but definitely good to take pictures of and make notes of in your assessment. And we had talked earlier about baffles or flumes inside culverts. Here's some really great pictures of those baffle or flumes inside of culverts. They're good to note. And as you can see, this would actually be a really intense culvert to survey just because there is multiple series of water stop or water drops within the culvert. That would need to be measured. And this may be a culvert that I would maybe recommend not to do as a barrier or as a culvert assessment, just because of the difficulty of getting inside. Sometimes these are tall enough that you can walk inside and you'd be able to do those. But if it's too small to get in, I would pass it by.
Can you describe where the actual flume is on the second picture?
Yeah, so this is you can see how it actually kind of flumes or fans out coming out of what would be a culvert. And this is probably going to be your, oh, why is my brain failing me right now? I'm sorry, my brain has stopped working on this Friday afternoon, apparently. So this is probably going to be outside of your culvert itself, and it fans out into a flume type situation where they're actually trying to backwater it enough to keep the water levels high. And that's where you can see all of these ecology blocks trying to actually make slow down the flow on this area. You can kind of see where I'm pointing at with my cursor. So they're trying to, this would be considered your flume, your baffled flumes.
One quick safety question. Do you ever have to deal with issues of confined space permits for entering into any of the culverts?
So Brad, good question.
Yeah, I think just for safety concerns, the answer to that is no, we won't go there.
We're not asking our people to go into the culverts.
Yeah, we're not doing that. I have actually gone through that kind of training because I've had to work in server rooms underneath floors and things like that. So I know what you're talking about, but no, we are not doing that. We're not going in things. you know, I mean, if you have to reach your arm back in because the culvert, you know, is rusted out a little at the mouth and you need to get an elevation of the culvert, something like that, you know, but, you know, don't start crawling into culverts. Don't, you know.
Okay, so you can measure the length of the culverts by optically through the tools you have?
Yeah, so we actually have laser rangefinders. And this is where if you can actually plan to work with a partner when you go out to do your surveys, one, it's safer. That way nobody ends up, you know, slipping and falling and being left out in a creek by themselves. But two, having a partner out in the field with you is great because somebody can stand at either end of the culvert and one person can be holding like the stadia rod where you can shoot the laser to the stadia rod to measure the internal distance of that or length of the culvert.
Of course, this means that you can't measure the drops if you have drops within the culverts.
Correct. And so you may not be able to actually fill out a full level A culvert assessment for a culvert like this that has the baffles inside of it. But it is worth noting, and you know, somebody else can go back out and complete that survey who does have the training and ability to go into those culverts.
You know, yeah, that's a great point that you brought up. You know, we got to remember we are, you know, we're like Sunday afternoon volunteers kind of thing, right? We are not experts at this, and there's no culvert that is worth us assessing. You know, that all puts us in danger. And you may find a culvert. You know, we're going to be walking down the bank of a culvert tomorrow that you're probably going to have some help coming back out of. I know Steve had to have get a hand, you know, to help him back out the other day. But you're going to need to assess the culvert just to begin with on whether it's even safe for you to do. And obviously when you're looking at it on a map, it's almost impossible to tell that. And you may get to a culvert and say, you know, that's just too steep. I don't feel comfortable, you know, walking down, 10, 15 feet on that steep embankment, and that's fine. You know, move on to the next one. Safety is obviously our number one concern for everybody being participating in these activities.
Yes, absolutely. So moving on, we don't need to worry about the baffle data collection or the fishways. These are just good examples of what they are and good to note in your assessment while you're doing your overall site evaluation. And these are good pictures of stream bed control rather than fishways. Generally man-made structures to help grade the stream after the installation of a culvert. Oop, catch up, computer. I apologize for my insanely slow internet today. That's grade control. So subsurface flows, I just wanted to touch on this really quick. Subsurface flows are generally not going to be fish-bearing streams or creeks, which means we won't be doing a site evaluation for anything that has a culvert below a subsurface flow. And this is a really good place to note, looking at your overall site above stream or above the culvert and down the culvert is a great way to determine if it is a fish-bearing stream, if it's not listed on one of the websites. We won't be looking at gradient barriers. And actually, so while we're here, I'm actually going to go back and go through the level A assessment form again. Oop. I apologize, it is being incredibly slow. And as you guys can see, we're actually on the barrier assessment website or the BAT team website with the Washington Council. And we'll go through this site here in a minute and kind of show you guys how to get to the barrier map and all of that kind of fun stuff too. So you can do some of your pre-planning before you go out into the field. So when you're filling out the level A assessment field form, as I said, we'll have our site ID. Most likely you'll get that site ID from the BAT website or DFW's website. Culvert number, that is the, remember we, if you have one culvert, it would be 1.1. If you're on culvert, if you have 2 or 3 culverts in there, as I said, you do one of these culvert assessment field forms for each one of those culverts. And so say you're looking at the second culvert in a group of them, maybe this would be culvert 2.2. So culvert number is the number or the culvert that you are working on. Materials, again, we went through that, whether you have precast concrete or timber or PVC, you would check one of those boxes on the type of material. The span and the rise, remember those are the internal measurements of the culvert itself. Span is how wide on the internal, and rise is how tall. And remember, we are measuring those at the widest point of the culvert. Water depth in the culvert measured from 6 inches inside. Shape, whether it's round, box, arch, or other. Your water surface drop. Water surface drop, remember, it can be all of the above. So you may actually have multiple water surface drops at the outlet, the inlet, and inside the culvert itself. And when we measure the water surface drops, you can make notes above outlet, inlet, interior, whether if you have all of the above, you want to measure all of those, but you want to, your biggest water surface drop is going to be the one that you record. Apron, there's the word I was trying to remember earlier. So your apron, whether it has one, either none of them, or upstream, downstream, or both. Remember total length, if it has an apron on it, you're going to be measuring the total length, including the apron. If it doesn't have an apron, you're going to be measuring just the total length of the culvert that's within the water. Culvert slope.
Hey, Erin,
Yeah.
quick question. Sorry to go back. So water depth in culvert, you said 6 inches back. Yeah, so the question I have is, if I have a culvert that's countersunk, do I measure from the top of the water to the top of the debris, or do I measure to the invert?
To the top of the debris.
Okay, so if it's 6 feet from the top of the water to the invert, but 4 feet of that is debris, then the water depth is only 2 feet.
Correct.
Okay.
But you need to include the whole distance in the span.
Correct.
So the span is, and that's why you have these gravel probes. You may have to probe, 3 feet of fill to hit the culvert. And so then you're going to measure, the length of the probe is into the sand, then the length, and add those together to get the full span of the culvert.
Right. I got that. I was just
Okay,
making sure
all right.
that I understood the water depth.
Yeah. Yeah.
Because, the amount of debris could affect that. So
It definitely. Good question. Yeah, I just wanted to make sure that I was understanding and you were clear too. So perfect.
Brad, can I clarify, I think you were talking about the rise, not the span.
Thank you. I was
Yes.
talking about the rise, not the span. Thank you.
Okay.
Yeah, I got to get those terms straight. Yeah.
And then we have the culvert slope. And remember, slope is the upstream elevation minus the downstream elevation divided by the length. And we will have instructions on those with all of our field forms. But it's good to remember what the culvert slope is. Road fill depth, remember we are measuring from the absolute bottom of the culvert to the crown of the road. And this is a loose measurement into the nearest meter. Countersunk, yes or no? Remember, it has to be 20% or more of the culvert is countersunk, and we determine 20% or more based off of how much material is in there and the whole rise of the culvert itself. Backwatered, yes or no, or unknown. Generally, it's not going to be yes, most likely no, never know, unknown. Gate, yes or no. Again, if you've done your homework, we shouldn't be having any gates on there. Racks, will run into some of those tomorrow. I'm excited. And fishway, yes or no. It's good to note, even if you think it may be a gradient control, you can still put yes. Sometimes it can be hard to determine whether it's a fishway or stream grading. Then we have our channel description, our bank full width, and then our span over bank full width. Remember, our span is number 6 up top. And then tidal influence, yes or no. So we don't ever get to run into that over here on the east side. Obviously, we have no tidal influences on any of our creeks or streams, but you may run into that over where you guys are doing some of your measurements, especially out on the coast. And plunge pool description. Remember, our plunge pool length is measured from the end of the culvert to the first rise from the bank, or I mean from the pool itself. So we are not measuring underneath the culverts. If the pool goes underneath the culvert, we are measuring from the end of the culvert. Pool depth or pool maximum depth, and our pool scour line width. And so remember, sometimes we will be measuring some of these culverts where there is minimal to no water flow in them, and we have to use our best judgment on where that pool scour line is. And for just a quick note too, for those pool scour lines, we're measuring at the widest point of that pool. And then we'll go through the flow chart to determine whether it's a barrier, yes or no, or unknown. This is a level A, so you'll be checking a level A assessment. And remember, for percent passability, we're using the most restrictive from those flow charts, the most restrictive passability from all of our descriptors for this culvert. And significant reach. Give me just 1 second. So significant reach, remember, we are looking at the full length of the stream when we're going over a significant reach. And so I'm actually going to move on to our barrier assessment website, our BAT website. So when you go to Washington Council's website, there is a tab called the BAT tab. And it's been used interchangeably as the barrier assessment training, but we're calling it the barrier assessment team. Hopefully one day we can get our matching hats and shirts. So they did a great job putting some information on the barrier assessment team website. But as you scroll on down through here, you have these tabs up top. You have the training slides, our training video that I had discussed about being able to look at really quick, less than 15 minutes, gives you a great catch up and refresher course if you're headed back out into the field and it's been a little bit since you've done a barrier assessment. And here we have our BAT map. As you can see, most of the stuff that has been done for the council is all Western Washington. But you can zoom in here and click on any of these little dots and get information about the site that you want to visit. And so there's great information here about the site. So this one's in the South Fork Snoqualmie River. It gives you the site ID number, the longitude and latitude, and what kind of passability it has. And I think I actually will have to go on to the full map to be able to get all of the information. So we'll just click on one of these dots. And yeah, so here you can scroll through all of the information about that barrier. And you can actually click on the previous survey forms that they've done and get far more information that may be helpful to you to go out into the field with. Gives you directions on how to get out there. And if you keep scrolling down, like you can see, so this one, the last time that it was surveyed right here was in 2000. So it's been well over the 8-year mark and would definitely be a candidate for somebody to go back out and resurvey. And so these old surveys are great because you can actually go through and look to determine, you know, is it a significant reach? Does it have fish potential? And some of the other kind of relevant information that you'll need for your level A assessments. So as you can see, there's a lot of information that pops up on those. Actually, trying to get out of that. Little screen keeps pulling down the information for the there we are. So on that map, sometimes you'll see that they have done multiple surveys. And so if you click on this little area right here that says next feature, you can find the second survey that's been done of it. And sometimes you do have to be careful. They will have multiple site IDs on them from multiple surveys. So it might be a good idea to print out those surveys that were done and take those with you, include those multiple surveys to take them with you when you're out in the field. And then I do have pulled up the Washington map or the DFW map, and you can see, zoom out a little bit, the big blue dots for the Washington or for the DFW map shows you the amount of barriers within that region. So like out here on the coast, there's, you know, well over 1,000 barriers on some of these creeks and streams. Eastern Washington in the less, I guess you could say, civilized areas that have been inhabited and developed There's not as many that have been surveyed. And so there may be some, like I said, that are not surveyed or on here. And it is worth noting too that the Forest Service actually surveys culverts and barriers on their lands, and they aren't actually attached onto DFW's website. So there may be surveys for Forest Service properties that aren't going to be on here, but they do exist. But it's still good to go ahead and survey those anyways and get those added into the barrier websites. Zoom into some of these. Actually, I'll go back to our BAT team website. So on here, right at the top, it says, click here to update assessment status of this barrier. So when you're going, if you've gone out and you've surveyed this barrier, you'll click here and it actually takes you into a login, and you'll get your login information from Brad and be able to input that information into our BAT website. It can once it's been input onto our BAT website, it can take about a month, but it will end up back onto that DFW website so that others can see the barriers that you have assessed. And when you're filling out the barrier assessment form, it does have a section at the top for the name or the crew that was on that barrier assessment. And you can use just your last name, initials, or your full name if you're comfortable having that published onto the DFW site. And up here you have your DFW manual. This is the full barrier assessment manual that has been published by DFW, the one that was updated in 2019. And as you can see, my computer is being slow and not downloading it, but all of the information, if you have any questions about your barrier assessment, or if you need some refreshers on the criteria behind some of those questions on the assessment field form, they can be found in this manual. And then reserving kits. So pretty easy to log in online really quick and reserve your kit to go out and do your assessment.
Two questions. Where do you pick up your kit and how long can you keep it?
Brad.
Okay, so right now we have had 2 people who trained a couple of weeks ago, and they have agreed to keep kits at their houses. So we will get that information to you, so you can work with them to pick it up and then obviously drop it back off. As long as you can keep it, you should only keep it as long as you're actually using it. You know, we want to get it back out into circulation as quickly as we can, because as we get more and more people trained, you know, there's going to be more and more demand to use the survey equipment. So, you know, I would say a week. You know, like, let's face it, most, you know, if you're retired, you can go out during the week, but, you know, most people are going to probably end up doing it on a weekend. And so you could pick it up like on a Thursday and then go through it on Friday, make sure, you know, the batteries are all ready to go and everything's set to go. And you go out either Saturday or Sunday. And then, you know, on Monday, let it all dry out and clean it up and then get it back to the person you got it from. So, you know, unless you have, you know, several weekends planned with people, then, you know, then that's fine. As long as it's.
Yeah, I was just thinking ambitiously, if my wife and I had decided to go for a week camping to do a couple of assessments during that week, you know.
I think that'd be perfect.
Yeah, okay.
Yeah.
How do you prioritize or decide what barriers to go out to assess or what barriers need assessment?
So we're actually currently, there's not really actually a defined list of barriers that we have prioritized. I think we are trying to work on that eventually to have a prioritized list, but using the barrier map on the BAT website, these really are the identified sites by DFW that are needing to be resurveyed. So this is a great tool to come and look at. I mean, you can see all of the dots on here of stuff that needs to be resurveyed.
Are the colors significant?
Yeah, so like a green one is actually going to list it as 100% passable, not a barrier. The one,
But you'll also see the date on there that she hit on was 2007.
yep.
And so that needs to be resurveyed. Anything anything before 2012 needs to be resurveyed.
Okay.
Is there a map that filters for those that are older than 8 years?
And that is this BAT map. This has filtered out the ones that are 8 years or older.
And is this map, does this have all the known barriers identified, or just the ones that somehow have been assessed and entered?
Yeah, not all the known ones, because we already had one of the people who's already trained. He went out and he assessed 3 barriers, and one of them was not on the map. And that's why we actually had to get new numbers so that we could add numbers to that. So it's very possible, especially if you get out like on Forest Service land or, away from roads, obviously we don't want you out on state highways, but, get away from, sort of heavily used back roads. It's very possible you will find culverts that are not on this map. And then you should go ahead and do the assessment and then get hold of Steve or Nick, and they can get you a number for that culvert.
And maybe this will be covered another time, but in terms of, is there a way you can find out if people are trying to assemble teams to go out? I mean, I don't know if I've got any friends who are going to want to do it, so I'd be probably looking for others who are interested and want to do it some weekend.
Steve, you want to take that one on?
That's actually the next item on our to-do list here, is to put together a system that will allow people to basically put up some kind of notice that you'd be interested in doing this, and when and where and whatnot, and then put it in a situation probably on the BAT website. We're probably going to put some kind of a scheduling option that will allow people to connect with each other without having to go through a lot of other steps. But we're not there quite yet.
In the meantime, what I will do is, after you folks are all trained, and we'll have a distribution list in email of people who are trained, and I'll just send that out so that you have each other, right? And so if you say, hey, I'm ready to go out next Sunday, I'm free, starting at 9 o'clock, anybody want to go? Hopefully you can find someone to go with you.
The other option that we're looking at is we have a volunteer, Nick Ulacia, who is agreed to be a volunteer BAT program coordinator. And we're working towards a point where he will be the basically one-stop shopping for any questions about a lot of this stuff. And he is, in fact, right now putting together a list of suggested culverts for people to look at that we'll have it, and we'll get it into your hands. And it'll be a shorter list than the map here. So that's the type of stuff we're kind of driving towards, making it easy for people to connect with each other.
And there are a number of local land trusts or other groups that you may also contact that have properties, private properties and culverts that they want to have assessed. And I know for the eastern side of Washington, since most of the BAT map hasn't gotten to the eastern side of Washington yet. The Yakima Basin in particular, I am working with some of our local groups to maybe get a prioritized list of culverts that need to be assessed in the Yakima Basin.
And Erin, we can start working on getting the map updated too.
Okay.
Yeah, so let's, in fact, I'll send an email to Luke, obviously I'll copy you, and he helped put that together. So let's get him involved so we don't have to recreate the wheel, and see if we can get some culverts in the Ellensburg area for now, and then we'll keep expanding as training expands.
Yeah, absolutely. Do we have any other questions from folks that maybe we can answer on today's call before we go out to the field?
On this map, down at the bottom of the map itself, over to the right, there's a brown circle with what looks like a funnel on it. Is that something you can specify filters with, or?
So yeah, you can actually click on that and you can break out the map by different types of features. So say
Okay.
you have, you know, an affinity for Chinook and you want to go and survey barriers that are known Chinook bearing streams. You can filter out by that. It's basically just a map or a section to create filters on when you're looking at what culverts you want to survey.
Okay, and it's just up to us to select, off this map, or filter it however we want to determine which barriers, potential barriers we want to look at.
Yeah, and if you have any questions about maybe you're going to be in a specific area, you can always reach out and see, you know, are there barriers in this specific area that I'm headed to that need to be surveyed? You know, as a team, we're a great resource to be able to help you guys out in choosing. I know at first it may be a little difficult to, you know, put a pin down on a map and say, I'm going to survey these ones.
Right.
And we're going to work to help you as much as we can, because the reason being is because we know the same challenges, right? We haven't been doing this for years by any means, right? And so we are new to this, and we have gone through those same challenges where it's like, okay, so I want to go assess a culvert, you know, where do I go? What do I do? How do I, you know,
Right.
and so, you know, make sure you're calling Steve, calling Nick, you know, and talk through it with them, and they'll help you as much as they possibly can. And also by asking your questions, you will help us understand the hurdles people are having, and we can work to alleviate those.
Great.
Any other questions? And don't worry, if you guys have questions that come up later on tonight, we've got our awesome in-person training tomorrow where we can answer some more of those. And hopefully that hands-on training tomorrow will be able to really solidify this kind of pre-training that we did today, and answer any questions that you may have.
Yeah, we certainly don't expect you to understand this till you get out and actually put your hands on the gear and figure out how all this is done. And that's why we're having the in-person training. Erin, thank you very much for your time and effort. You did a wonderful job. I'm incredibly impressed. And I'll also tell you folks, I continue to learn stuff. This is my third time through this now, and I continue to learn. So there is a lot to learn, and you'll keep picking it up. So tomorrow we will see you 9 o'clock. As you come into the parking lot, veer to the left and go up the hill. You'll see my F450. It's silver, and I'll be parked up there, and we can all sort of park in the same area and Also, the parking lot gets pretty full, so I think that area gets used last, so we can tuck in up there. We can, we'll, start using the gear right away. We'll break up into 2 groups and we'll answer any questions we possibly can. If there's something I can't answer, I'll ask Erin. And if she doesn't know it, then we'll try to get hold of Luke Kelly, Luke has actually surveyed hundreds of culverts out on the Olympic Peninsula. So he has a lot of hands-on training, and most of the time, though we caught him on something last training that he had to fix. So he's still learning too, but we will continue to improve and upgrade this as we go. But I'm excited to see you all tomorrow, and we'll see you then.
All right, see you tomorrow.
All
Thanks very
right.
much.
Thanks, everybody.
Thank you.